like to introduce our first speaker, Frank DeFalco. Frank is the Director of Member Relations for Next Generation Manufacturing Canada, better known as NGen, and leads the Supercluster organization's technical advisory boards for additive manufacturing and automation and robotics. Frank, I'll pass the screen and the mic over to you.
Thanks, Michael. Glad to be here. Let me just get my presentation up here and share with everybody. So again, thank you. And as Michael said, I'm with NGen. And I'll tell you, this is what I'm going to be talking about today. I'm going to talk a little bit about NGen and tell you a little bit about what we do with our funding. And then I'll talk a little bit about additive manufacturing, the landscape in Canada. Then I'll give you some additive manufacturing case studies. I think that'll be interesting. Then a couple of tips and some of the additive opportunities that you see available to companies. And about that, we'll go into a little bit more detail about the additive manufacturing demonstration program. Then we'll open it up for Q&A. Okay. So if you have any questions, just put them out the Q&A, and then we'll get to it at the end. Okay. So Next Generation Manufacturing Canada leads the Advanced Manufacturing Supercluster. That was a program developed in 2017 by the government. We have 5 superclusters across the country. Won't go into one. Just supposed to say that we are the Advanced Manufacturing Supercluster. We're committed to building a world-leading advanced manufacturing capabilities for Canadians and Canadian companies. We want supporting and strengthening collaboration, and that's really important in collaboration across Canada's advanced manufacturing ecosystem. We want to support skills development and advanced manufacturing capabilities, and we co-invest in collaborative industry-led projects that have the potential to create unique competitive advantages for Canadian manufacturing. We have over 4,000 members and counting, so it's a good thing here. So let me just go to our next slide. So what does NGen do? Well, like I said, we have funding programs. We were allocated $230 million for collaborative, innovative projects. And to date, we have over 120 projects in the works, in the pipeline, either contracted or about to be contracted or completed. And these will all be completed by the end of our mandate in 2023. I'll get back to one. Hit the button by accident there. We also do collaborations. All NGen projects are collaborations. So we have stuff like a collaboration corner where you can post your project ideas, and the idea of looking for a collaborative partner to maybe do an NGen project or just simply do business. We also have programs for workforce development. AMP Up is something you may want to look in, where we will give up to 50% subsidies for training costs. And this is with leading institutions across the country. So they would be business and advanced manufacturing related training programs. So you may want to look at that on our website. Some of the different projects, we have pilot projects and feasibility studies. These are for SMEs. And the idea is to de-risk for the manufacturing development and implementation of projects. Feasibility studies can go up to 200K. The pilot projects can be up to 500K. Again, they are collaborations between 2 SME partners. We have supercluster projects, which at this point we aren't entertaining any new till we get recapitalized, but these were projects between 500K and up to 20 million. A lot of exciting projects being done under that particular thing. And just announced, for everybody out there, we have NGen's Automotive Zero Emissions Manufacturing Challenge. We're going to invest 20 million as part of a new challenge program for to position Canada for success in the global shift to zero emission vehicles, ZEVs. I would have a look at that. We just announced that last week. So, and another project is the Additive Manufacturing Demonstration Program, which I'll get into a little bit later. I want to talk a few things about additive first of all. Okay, so our projects, they need to be transformative. So you need to be global. It has to be really, really special, not just your run-of-the-mill adoption of putting a robot on a production line. It has to be innovative, need to be applied. And as I mentioned before, collaborative and enduring. We want to make sure that what we fund will be, a manufacturing process that will be existing in Canada for years to come. You won't have a need to go look for lower labor costs and jurisdictions to be competitive. The projects you'll do with NGen won't have to rely on that. It's an idea of bringing in new technologies to a manufacturing process and creating something that's truly special globally. Okay, so talking about additive manufacturing. Okay, so here's a interesting fact. Okay, so the Parts manufacturing, additive manufacturing parts grew annually to 6.8 billion in 2019. Okay, that's a growth of 20%, has been sustained for a while now. Okay, uh, that is only a small fraction of the $14 trillion global manufacturing output, which has a 1% growth. So as you can see, additive is growing as a larger share of manufacturing. It's not to say that it's going to replace traditional manufacturing. That's not the case, but it does have a sweet spot. And I want to get to a little bit of that in this presentation of introducing case studies. It can produce better solutions to certain problems. It offers reduced waste, increased agility, factors in the value chain, goods for healthcare. It's good for energy, aerospace. Applications are almost limitless. It's very, very few manufacturing shops or anything that can't take advantage to having a 3D printer available. Okay, just to show you, this is a map that we put into a recent report I'll talk a little bit about in a moment, where some of the manufacturing equipment producers, academic research facilities across Canada, like in the east, we have the PEI, we have like Trosnojet. They do some really, really interesting metal additive stuff for the aerospace sector. You come to Quebec, there's a lot going on in Quebec. Companies like Aeon 3D are building a great FDM 3D industrial scale printer. If you need that, I'd have a look at them. There's companies like Axis Prototype have been doing that for a while. They really, really know how to take advantage of the technology. Coming into Ontario, I have companies like AMM. I'm going to show a case study from them. Burloak, companies like a Mosaic 3D have created a brand new, which Engen helped fund, 3D array printer. Just help. The idea is to get to production. And much of what we're trying to do at Engen is to introduce additive as a production option, not just as a prototyping. Prototyping is great. It's been done that for a while. Going west in Manitoba, we have Precision ADM. It's one of the world leaders in medical device building and additive. They do some really great stuff. I'll show something about on them afterwards as well. Going west, Alberta, you have Exergy, great company coming out, really doing some stuff in the energy sector to really help make the energy sector greener. Going to BC, there's companies like Tinkering. Tinkering's got a great desktop 3D printer, and they really focus on the academia and educational and training purpose. Sector. So if you're looking to learn about a 3D printing, they've got some great resources. UBC, there's Academia Waterloo, great universities doing a lot of great work. UNB out in British Columbia's got their Marine Center, which is really doing some interesting stuff. Okay, so here's a breakdown. As recently at Engen, we did a Canada's additive manufacturing landscape, where we surveyed the 30 experts representing powder producers, machine manufacturers, service bureaus, researchers, academia, and industry users. It's a diverse group, and we tried to get their pulse on Canada's landscape at additive. And so I invite you, you can see the link at the bottom here if you're interested. It's available on our Engen website. It's just a year old, so it's still very, very relevant. And this is something, as Michael mentioned earlier, is I do lead the advisory board at Engen. So we regularly meet, trying to keep a pulse on where is the sector, what can we do to help, and how, most importantly, how can we help industry understand how to take advantage of the expertise that's offered around Canada. So let's go to a case study, okay? We'll come back to here's the case statement. This is done by Additive Metal Manufacturing. This is a group that's in Concord, Ontario, GTA, Toronto, if you like. And here's a program that I've worked with them to do just recently. This is just a few weeks ago. So it's with a company called AEM Power Systems, okay? So if you see the initial step file, okay, it's that top one, A, okay? It has critical internal features that have been designed optimized. They couldn't be changed, okay? So if you look at B and C, AMM was able to offer some alternatives designs with a few different iterations, okay, until they finally arrived to D. So it's hard to believe that they're actually the same part. They took the approach that would be print what was necessary. It's one of the big things is, why we call it additive versus subtractive or traditional manufacturing is you're adding the material versus, machining where you're removing the material, which, is a kind of a green component about it. I don't want to necessarily call that a very, very green technology. It does take a lot of energy, but that is an area that, there's a lot less waste. And, less waste is certainly a really important consideration for the world, right? So this, substantially decrease the size and mass, and as you do that, it becomes cheaper. Okay, so after the multiple CAD design iterations, the final design, you kind of see that again going top to the bottom. It was put onto the top. It's a 70% weight savings in weight, print time of 57%, and the price is a 50% savings. Again, because of those things where you have less print time. Most of the cost for additive is materials and print time. So if you're able to reduce both, well, then you get less than the initial design. Does that make it cheaper than a additive part? Well, no, you can't really compare that. That's something I'll talk a little bit about afterwards. So some of the benefits, is design freedom, speed to market, part consolidation, avoiding assemblies and tolerance to stack up, mass reductions, thermal management properties, and important is complex geometries. Okay, so that's a really interesting project, and I'm glad to help fund this through our AM demonstration program. So here's an interesting project that was done by Precision ADM. If you remember, they're the ones from Winnipeg. This was a groundbreaking project. This is one of my I don't know, feathers in the caps, if you'd like, that I was able to fund with just a 5,000 project. So you can see a pipeline inspection gauge. You can see the gentleman there putting it into a pipeline. So as it is, it's inspecting the pipelines, and you can see it a little bit better. I have a couple of other pictures, but the one of the great things is that when the company approached me about this, using additive as part of their manufacturing production, they weren't sure of the quality of the metal. Okay, could it stand up to the rigors of the environment they're working in? Right, it's a really, really, let's face it, it's oil and it's a pipeline. It's not some place where most machinery is going to hold up. So as I explained to them, if the company knows what they're doing and you get a quality metal part, it's superior, if not equal to cast, or superior to a cast. So it's a good way of doing it. So we funded the project. Okay, you can see here on the right is my contact over at OnStream told me, this is OnStream, the company that did this, is he called this his little terracotta soldiers. Okay, so that's the parts, the different parts built on a build plate. So you can see you get several amounts of them. So there's a little bit of economics of scale, not a lot, but there is some. But you're not looking to do millions, right? If you're looking at additive, you're looking for low production runs. So that's the area. If you're not looking to build hundreds of thousands or millions, if it's just hundreds or thousands, you may want to consider looking at additive as an alternative, because you can really, really shorten your supply chains and your time. Okay, so by consolidating parts, improving lead time, AM offered a solution to reduce costs and newly designed pig and improved performances while allowing design, this is important, design to dictate form as opposed to manufacturing techniques. So you really, really are allowed to envision, how would I like it to look like? And then not, there's always going to be constraints with whatever technology you use. That's true. But the idea that you do have a whole bunch of new freedoms and a whole bunch of concepts to consider, you can consider as new ways of building things that are exciting. So that's a great, just to let you know, okay, when I did that with a $5,000 project, okay, the company now is buying $1 million worth from the service provider. So and the Precision ADM's become one of their main service providers and sourcing of products. So they started with one part, now they're using many parts as you start to investigate. Now, here's another one. Okay, so another area that is really interesting for additive is, and a lot of, we're talking about automation or robotics, is lightweight robotic end of arm tooling. Okay, so here you can see a part that would have been traditionally put onto some assembly line. Okay, if you can see the pickers there, and this is done with an SLS technology, and it's a polymer, so it's but it saves so much money over a machined aluminum one that it took 3 years. As talking to Annabis Starwet over there, why take the risk of replacing an aluminum mill part by a plastic 3D printed part? it took 3 years to really convince the clients that, this is really a technology to look at. And the complexity, as you can see the design, if you just look at that, you can't machine that, right? So when you get lighter, anytime you put something lighter on a machine, the ability to make it last longer, that's less strain on a machine. It doesn't have to work as hard. It's got a lighter tool. So there's so many advantages. It's really, really a particular area to look at for assembly line and end of arm robotics. One of the really interesting parts of additive that's only starting to really take off. Okay. Burloak, some of you may know, Burloak is in Oakville. It's Division Samuel. This is a project they did with MDA. So this is a satellite antenna parts. These are, again, space, aerospace. These are the sweet spots for additive because you're not making millions of satellites, right? You're going to make a few, if not maybe just one. So you don't need a lot of parts, okay? AM allows designers to consolidate one item on one assembly subpart that would traditionally be comprised of multiple parts, right? So you can take, including parts, flanges, fasteners, assembly effort, putting them together. So you save even money because you're not having to assemble those parts. It allows for smaller packages, mass savings, and designs that could not otherwise be conceptualized. You can't do that again with a CNC machine. As great as CNC machine is, it's great. And one of the things you have to remember is additive isn't going to be replacing traditional manufacturing. I mentioned that before. It's a new tool. I'll talk a little bit more about that afterwards. Okay, so I want to talk of I never know how much time I'm going here, but some of the opportunities and tips available. So again, when you're talking about AM, think about part consolidation. Okay, so you can save so much if you have a part that has the fasteners and clamps. It's hundreds of parts, and you design it. Suddenly, you remove those hundreds of parts, and you think, okay, great. Now I don't even have to assemble those parts, so that the time saving is there. But also, you have to consider the overhead, the paperwork that each part entails. When you're in business, you always have to do inventory. You don't have to count hundreds of parts anymore. You count one. So the savings can really be substantive once if you look at the whole life cycle of a part. Freedom of design. Again, I showed you some of those parts we did. The design of complexity is a whole new thinking you need to do. One of the interesting little stories I heard, or not a story, is traditionally when somebody's designing let's say a channel for a manufacturer part, okay, they're going to make the channel circular because they're going to drill it, right? Well, you don't have to consider that. You can make it a square channel or triangle channel. Maybe there's ways that the flow works better in a different sort of configuration. And it doesn't make a difference for time because you're additively doing. You're not drilling that hole. You're just not putting the material that was where the hole was to be, and it could be any design. Lower inventory costs. What's interesting about that is you wonder, well, how does that work? Well, instead of storing a part, you can actually store a CAD file. And when you need the part, since the lead times can be very, very quick, the 3D printer, like, okay, I need this part. My customer needs this part. I don't have an inventory, but I can make it in 2 days or 3 days and then ship it to them that way. I remember reading a story about Mercedes bus company. We're looking to transform into a virtual inventory of parts. And then, if everybody knows that when you're trying to predict what parts you'll need in the future, and you don't want to have to keep the tooling available for it. So you're going to make that many more in storage. And, you could predict wrong, right? You might predict that there was another part that you need a lot of and you didn't make enough of those. And if you don't have the tooling, that's a really, really expensive proposition to consider. So that's a really good area to look at. And I think we'll see that a lot more in the future. Lead times, days versus weeks. That first project I showed you by AMM, okay, I talked to them in July, and they've already got the part, and that was about 3 weeks. So that was with the design iterations, and that they got the part in 3 weeks. So, trying to do that in other conventional, it's just not possible. You have to talk months, and it's, not particularly more expensive. To the ability to replace legacy parts. especially pumps. There's a company, even KSB, I believe it is, where they learned that, pumps can last decades. And if a part breaks, it could be very, very difficult to find a replacement part. Does the company even still exist? So this, you can do reverse engineering fairly quickly and do a part additively without having to build a mold and all that. And it's something that's really starting to be looked at. So some of the tips, okay, introducing additive manufacturing to a company is a cultural change. It needs to be a top-down leadership, and it needs a top-down leadership and patience. It needs to be patient. Learn about it where it best fits. Okay, so not every application needs to be additive. Through the running of my demonstration program, I've learned that sometimes the best advice I can give a company is, no, additive isn't for you at this time. Keep using traditional. As somebody, the head of EOS once said, if you can build your part traditional manufacturing techniques, keep doing that way. But if you can bring in some of the new design for additive manufacturing, where we talked about the opportunities there, maybe it makes a lot of sense. It's good to have a champion in an organization to build success stories and then let it organically spread amongst your designers. So it's kind of, you're not going to change things overnight. It takes a little bit of time. Understanding that designing for additive manufacturing is a skill that needs to be learned. You don't do this, as that quickly. It's like taking a part that's designed for milling and send it to an injection molding company to build it. It won't work. Simply taking a part from inventory and getting a quote for it when you get that is the wrong answer. It reminds me of a project we were doing with a company where they sent us a part, and it was a fairly simple circular part, metal machined, and they asked us, well, can you 3D print that? And the answer was, of course we can, but would you? And we asked, how much do you pay for that part? And they said, oh, it costs us $30. And when the idea, well, if we're going to metal 3D print it, it might cost you $2,000 or $1,000. It's not competitive. So again, if you're getting something traditionally, don't, it's very, very rare you can see a part that can be made traditionally where you can competitively do it as a metal 3D printer, particularly, So introducing, it's part of your toolbox, okay? Understanding that industrial 3D printing is like adding a DeWalt cordless drill to your toolbox. It can make a big difference, but on its own, it's not going to do a heck of a lot, right? Well, you need to know what to do with it, okay? Additive is the same. It's a new and very, very powerful tool in your toolbox. It can make your company more competitive. It can solve problems, and you can gain an edge. But you got to know when and where and how to use it. Those are very, very, very important considerations. So on to the NGen's additive manufacturing demonstration program. That's something that I've been running for quite a while. Before I was part of, some of you may out there in the world may have known I was the lead over at Canada Makes, and one of my responsibilities was to run this program. So I've seen hundreds and hundreds of programs, companies come into the program, and we've engaged, and I've told them sometimes, no, additive's not a good solution, which I found that very, very useful. Sometimes companies are curious, they hear a lot of hype, and this is good, hype is good, but sometimes it builds unrealistic expectations. And really, one of the goals it has about this is to, let's try and find ways where you can introduce additive as part of your production. As I mentioned before, it's really, really useful for prototyping. That's been established for a few decades now, even. So, but the idea is, how can you use it in your program, in your production? And I showed you a couple of examples there. Okay, so the requirements to participate: companies need to be NRC eligible with a referral from their ITA. If you don't have an ITA, I would go to the concierge service at NRC IRAP, and it's a great service. IRAP is it's a free service available to all Canadian companies, SME companies. I think you have to be in business for a while, but I look at that. You'll need to provide a CAD file. That's not something we cover in this program. The cost, the program is about $5K. It's not a lot of money, but it's really, really easy to use. Like for a company to participate, all I need is that email, and then we're ready to go. Then we talk about your project and see if it makes sense. And if it does make sense, we then talk about a service provider, what sort of material you want to use. You know, there's not a limitless amount of materials. It's still one of the things in additive that's growing, and it's growing a lot by the day. New materials, you know, some of the more standard ones are 316 stainless, of course. A titanium is a popular one. Um, there's a few there in canal. Anyways, we can talk about it if you need. If you find you have a part you want to look at that needs certain properties, and we do also plastics and engineering grade plastics like a peak and all that. And again, we can talk about it if you're looking to try that. And again, we would need a CAD file. Okay, so that would be one thing you would want to. So if you're interested, you can contact me. There you can see frank.defalco@engen.ca. You can go on to our website. If you can see the link below there, you can get NRC. You can talk a little bit more detail about the project. Okay, so that's concludes for me. If you have any questions, I'm open to questions, and hope it's been informative. And I thank Dex and Michael for this opportunity to talk to you about NGen. NGen is really out there for companies, for Canadian companies to really be better manufacturers. And of course, additive is getting to be a more and more industry 4.0 technology. So I'm going to stop sharing, and I'm open for questions.
Great, thank you, Frank. That was a really concise sort of summation of the ups and downs, or the advantages that I don't think a lot of people necessarily recognize. When it's appropriate to use it, and how you have to sort of think in a very different way, don't you, about additive manufacturing? Like it's not starting with a block and taking stuff away. It's you're trying to figure out how not to print material,
Yeah,
instead of
it's really less is better,
Yeah, exactly. I was going to ask you so if somebody is IRAP eligible, and if they have that, what is it that the program provides? Is there funding for so they would receive money to
so it's really
print
easy.
the part?
Okay, so sometimes people find it hard to believe. They think there's got to be a catch to it, but as it is, it's not a lot of money, right? I have maybe 5 to 10K per project.
Sure.
So what I like to say is that'll get you a part about the size of your fist if you're doing metal additive, okay? And then we're talking, you can do different technologies, but mostly it's going to be a powder bed solution, a DSLA, or an EOS machine, or a Renishaw machine, where you can get some pretty good detail. So, so that's the idea. So you get that. I get an email from the ITA. So all company does is contact their ITA. First of all, they can contact me and we can talk about that. We don't have to, I'm always ready to give advice about additive and talk about it, even if they aren't ITA, IRAP company yet. It's maybe something they can do. And I'm still, very, very, pleased to tell them about how they can take advantage of it. So yeah, all they need is to have their ITA send me an email saying that they're IRAP eligible. That's it. Then we talk about who's the service provider, what material, local, not local, whatever it is. There's limited capabilities. Not everybody has all capabilities, right?
Sure.
And then, as I like to say, the company gets the part, I get the invoice. That's it.
And so, what does it mean to become IRAP eligible? How does that work?
Okay, so I'd like, you have to be 2 years in business at least, and
Sure.
you have to have done business, not just be a company. And so I always like to, as I say, contact a concierge service at IRAP. They will tell you, and then you have to meet your ITA, your local ITA. They would come and make sure you're not, as we say, a fly-by-night company. So it's a service available to all Canadian companies. It's a free service, and IRAP projects can go a lot more than just 5K. They can go up to a couple $100,000. As we like to say, IRAP is kind of like, companies will do IRAP, the small SME company will do IRAP, and when they want to do something bigger, they come and see us. Or smaller, we'll do the smaller, bigger, but they're that spot where they're a little bit more TRA level, a little lower, not quite to market. We look for, apart from the additive demonstration program, our NGen projects are very much close to market. We look at the end of your NGen project, you're commercialized and ready to go to market.
Gotcha. What do you think? You mentioned that it took one company, I think the robotic application took them 3 years to sort of get on board with the idea of additive manufacturing, and then I hear that a lot. But then once they do, they go all in. I think like that first example you said, they're really heavily invested in it. What is it? Is there a thing that you come across? Is there one thing that you come across that is that barrier to entry? Is it span?
Yeah, it's cost. Often it's cost.
Okay.
The sticker shock. Often what I would get, it's when I was at Canada Makes, is I'd get a company that would call me up. Often it'd be, let's say, a machine shop, and they've been hearing about the hype about additive, and they would say, oh, we're thinking of buying a metal 3D printer. And I go, hey, do you have a business case? Do you have a reason? Are your clients asking for it? And they go, no, not really. And I go, well, what's the most expensive machine on your floor? And they go, 100K. And I go, okay, well, if you're going to get a laser powder bed, I know there's cheaper technologies, but let's say laser powder bed, you're going to go, almost $1 million. And that is not even considering, let's say you want to do titanium, then you have to get a whole infrastructure because it's a hazardous material. Then you got to build that, and then rooms, and then before you know it, you're $1.5 million, and then you're going to need at least 6 months because it's very artisan-like. It's not plug and play and away you go. You're going to 3D print your parts. You've got to learn about the best orientations. You remember those little terracotta guys. It takes time and know how to best utilize the space you have for build chambers because they are limited in size. That is one of the biggest barriers, is part size too. Okay. It gets more expensive, and there's stresses and there's a lot of consideration and knowledge to be. So these companies, I was telling them, so you're not going to build a part in 6 months. You don't have a business case. I would say, wait, look at it and see if your customer base needs it, and of course the customer is going to be a low production. And that's why you see aerospace and medical as the really early adopters, but they're not the only ones. The energy sector, as you saw with the programs, as I say, I like to say almost any sector can take advantage of it one way or another. If it's simply your company has a little desktop printer that's going to make jigs and fixture to help everything, or maybe do a little broken part for a machine. These are all potential applications that might help. And these machine on the desktop, set you back a couple $1,000. It's not a huge investment, but it offers a lot of capability and a little fun even. They are fun.
Yeah. One of our attendees asked a question. It said, if somebody participates in the program and they get the 5,000 or whatever it is, can some of that money be used to, is it metal and plastic, or is it just metal?
It's been traditionally mostly metal, but
okay.
Some of my partners, or would you say some of the companies that were polymer based, were complaining and saying, hey, a lot of innovative stuff's being done in polymer. So we did change the program, and now we do allow for both. So
okay.
It has to be, they talk about engineering grade materials, PEEK and all that. Although what does that mean? They're all kind of engineer grade materials. So again, contact me, we can talk about it. Of course, there's going to be considerably less expensive than the metals. Metal and plastic, the prices are very different, but they can all make a huge change to a company. So that's why it's important. It's really, how can you take advantage of the technology? I don't really care about the material. When it first started this program, it was all talk of the world was metal additive, and it still is a little case. But again, it's where does it fit in? It's just a tool. It's not. One of the things I kept getting repeated on earlier is I refer to additive manufacturing as a sector, and some people would tell me, no, it's not a sector. Like, would you call CNC a sector? It's not a sector, it's a tool.
Yeah.
So, but it's a powerful tool. And there's a lot of companies that are focused on it, that are looking to become better companies, but it's hard to jump in. You really need to, as I said, to have a champion, look at it and design for additive manufacturing is so key.
Yeah. How is the IP of the design, of the part design protected in the program? I mean,
so as you can see, there's probably a lot more projects I might have been able to show, but the companies preferred not to. So
Sure.
there's a couple of ways we can go about it. Okay. I often get this request. So personally, I don't need to see the CAD file. I just need to ask the company a certain questions, like what sort of material, and where the gist of it is, and are they IRAP eligible? And then we talk about, let's find a service provider. I'll work with anybody, academia, industry. I'm only going to refer industry. That I find that it's important for companies who have put skin in the game, and it's not I'm trying to denigrate the academia. They're doing great work in R&D, but they are R&D, and they haven't put some of their own money into it. So, and I always tell my academic partners that I say, listen, if you bring a partner to the table, sure, I'll fund it. But if a partner comes to me looking, and we're looking at a service provider, that'll give you a more realistic cost, because really, the goal of the project is to get to production. And academia will give you a prototype, tell you that it works or not, but they're not going to be your product, service provider for production. That's going to be the industrial partners like Burloak or AMM or Axis Prototype or Exergy, Precision ADM. These guys have put skin in the game. They've spent the time to learn how to make your parts as best it can be made. So
Yeah. Yeah. Do you get into, is that something that participants in the program work through? Like you mentioned the material properties. I've spoken to service bureaus in the past, and I mean, they're really knowledgeable about the characteristics of the material, right? Whether it's a nylon or a powder bed kind of metal powder kind of process and stuff. Is that something that people usually work through with the service bureaus once they're into the program and they've been paired up with somebody and stuff? And that's the point at which they think about this material versus that material, brittleness versus weight versus some other kind of parameter.
exactly. Sometimes, I know a little bit better, through the years of running this program.
Sure.
I do understand a little bit about that. Like that pipeline inspection gauge, those parts, they weren't sure. Maybe they thought, and we thought, well, what about titanium? And they said, oh, can we? Because it's interesting, if you use titanium in machining, it's really, really tough to machine. But in additive, it's not it is more expensive of material, but not like it is if you're doing traditionally. So it's interesting that way. So when we introduced that idea, titanium made a lot of sense, even though they weren't fixed on the part. Again, also the AMM part, they weren't sure. They thought maybe Inconel, but let's maybe start with the stainless. So we just started with the stainless steel. And maybe that they were most important with the channels. The channels had to be smooth, and they couldn't deviate from that. But all the additive, once they learned about it, they were really, really happy with that. That suddenly that 70% less weight. That material, you just saw how much less it was. So yeah, but the experts, we will talk to them. We will find the right material for them and the right service provider for them. And like I say, I'll work from coast to coast. So I know most of them. So if any of you service providers don't know me out there, give me a call. Let's get together and talk and see if we can, maybe we can do a project together. I like to be agnostic. It's very, very important that I be agnostic. Don't prefer one technology over the other. Yeah, I just like to, of course, work with the people who I've worked with before. It always makes sense to do that. But again, it's a growing. I'm not going to use the word sector, a growing ecosystem. As if you go and see that report, when I first started, there's some of the companies that come on board, which I'm starting to learn again as NGen is kind of giving me the ability to focus on additive as a one of the industry 4.0 key tools. So
yeah. You mentioned how important it is to get to know this technology and understand it before really diving in. Are there resources where people can go, either students or people already in industry who programs or something?
That's actually
really
one of the training. I'm working on something. I'm working on what we're calling at Engine a technology adoption portal, with the goal of helping a CEO, give an example, a CEO to come in and get some agnostic advice on, is this technology potentially a fit for me? They've heard about the hype, they think, or they've heard their competitor dabbling in it. Nobody wants to get left behind, right? So, but again, we've also heard about these horror stories of a company meeting a great salesman who, sells them a dream, and then the machine sits in the corner. We've seen all those dust collecting machines that seem to be the greatest solutions to sliced bread, which maybe they were, but either you lost the person who knew how to function the machine. So a lot of things like that, that,
Sure.
yeah.
Yeah. And for engineers, for the more technical part of it, and stuff, because they're the ones who have to do that design for part of it. Is there something more technical that you
there are like, I know Mohawk College is working on something.
Okay.
There's like Precision ADM has got a design for additive program. There are some are internationally. I have to again review it, review what's available, but nothing that seems to have A to Z sort of training available. I do know that Mohawk College.
Sure.
There's courses at McGill's got a great program, and Mathieu Brochu is one of the world leading experts who helps the students. He's University of Waterloo, of course. They're probably the top in Canada for capabilities. They've just got a fabulous program and some great trainers and professors there. UBC, really, there are very few at McMaster, University of Alberta, SAIT College, Red Deer College. There's a lot of places doing it, but one of the areas that I mentioned is tinkering. Okay, tinkering has been focused on the K-12 for years, but him and I have been going back and forth. The CEO is Eugene over there, and finally, I remember some years ago we had a conversation. Oh, you've got this great tinkering U. It looks good. Can we use this for businesses? And he said no at the time, and he was wise. He was very wise because it wasn't ready. Now he says he's ready. So he's got some resources there designed for businesses. Again, nobody's got everything. Okay, so remember, additive is a lot of different technologies. There's seven key technologies in additive, and I didn't even bother talking about those because you can find those information online. There's a lot of different places, but there's no one spot. And I'm hoping to have that available on the NGen website in the very near future. It's one of the things before our end of fiscal year. I even have a few things up there right now. But it's something that needs, again, there's so much involved. To have a training course for one is you can have design for training, design for additive manufacturing training, and it's certainly going to be helpful. But again, it might just be for one technology, versus many technologies. So keep your eye out on the NGen website. I'll have something soon.
Sure. Okay.